Now looking at this here, the two lines intersect inside the circle. So the angle of the intersection is equal to 1/2 of the sum of the two angles. So at this point here, we can add the two together. So 85 plus 145, 0, 2, 30. Because 0, 5, yep. Multiply it by 1/2, and we get 115. Yes? Because if they intersect inside the circle, the angle is equal to the sum of the two arcs. If the angle is outside the circle, it's 1/2 of the bigger minus the smaller. Number 8. So are we good with this here? Okay. Okay. Seven. Okay. Number 8. So number 8 is set up like this here. Now, we can't use the set formula that we had last time because the angle that would work with, you're welcome, 2x minus 30 and 30, that side's still the same because we could say 1/2 of 30 plus 2x minus 30 is true, but we would actually be talking about this angle here or this angle here. Because these two here, like you're saying, they do add up to be 180, yes? So this angle that we have as a green dot, whatever its measure is, would be 180 minus whatever the value of x is. So we could call it 180 minus x. Yes? Question? Okay, I'm just making sure. Because they do add up to be 180, we can subtract that from it. Now, looking at this here, on the right-hand side, we can combine our like terms. 30 minus 30 is 0, just leaving us with 2x. Now, we can multiply 1/2 and 2x, because 2x is divisible by 2. And 1/2 times 2x is x. So we have 180 minus x is equal to x. Now we can get the x's on the same side by adding x. So 180 is equal to 2x. At this point here, we can divide by 2, telling us x is 90. Yeah, we can say 90 degrees. Not too much, no. Because for this one here, I believe it said x degrees on the problem, so it would just be 90 technically, because we're finding the value of x, not degrees. If it didn't have the degree marker, just said x, then we would actually say 90 degrees, because we're talking about the angle. Does that make sense? Because it, I believe in the problem said x degrees, and then this here had degrees, so it's just really finding x would be 90 technically. Seven. We are almost finished with chapter 10. We'll possibly do another one, not a full chapter, but we'll hit certain parts of it. Any questions on this here? we subtract. So 1/2 of the bigger minus the smaller. Outside is the angle is equal to 1/2 of the bigger minus the smaller. Inside, it's 1/2 of the sum of the two. Any other questions on these here? Now, 10.6, the first theorem we have is this one here. Now, this is the first theorem that we have that actually talks about length. Because we've talked about degrees, angles, we're talking about degree measures. This here, we're actually talking about the length of the lines, the length of these chords. Now, if two chords intersect in the interior of a circle, then the product of their lengths of the segments of one chord is equal to the product of the lengths of the segments in the other chord, or the other chord. So what that's saying is AE, different color, times EB. If we multiply these two together, they will have the same length as, or same measure as CE and AD. Let me pick that color. These here multiply together. Questions on this here so far? I have said this in years past, and I'm going to end up saying it again. I want to look at this one here first. And I believe if I probably looked at the video from last year and probably the year before, I will have also said at this point, I'm going to need to go back and reorder these eventually. And obviously that did not happen. Yep, I just keep forgetting to switch these. Because I want to look at these first before we look at the other two. Most likely. Now, when we talk about this theorem here, x and 3, if we multiply these two lengths together, so x times 3 will have the same value as 6 times 4. So x times 3 is 3x. 6 times 4 is, and at this point we can divide by 3, telling us x is, and that's it. Yep. Questions on this here? Now we're going to go back to, because that still holds true even though we have x's. Now in the end we want to find the length of ML and JK. So we'll have to find the value of x and then plug it back in. Now looking at this here, well, according to the theorem, Kn, so we can write this out, Kn times Nj is equal to Mn times Nl. Now, especially when you do the homework and are working it out, you don't have to write this out. I'm writing out so we use the theorem. Because this is what the theorem states. Now, Kn value is x. Nj's is x plus 4. So we're saying that x times x plus 4 is equal to x plus 2 times x plus 1. And really, after this problem here, we can start at this point. Now, the first thing we can do is distribute x for this here. X times x is x squared. X squared. And x times 4 is going to be plus 4x. Now for the other side, we'll have to do a little bit more distributing than we did on the left side. So we'll have to distribute the x. And again, x times x will give us x squared. X times 1 is going to be plus x. Then we'll have 2 times x will be plus 2x. And lastly, 2 times 1 is going to be plus 2. We have to distribute that out. Yes. Now, before we do any solving, we want to combine like terms. And the only like terms that we have are x and 2x. So x plus 2x gives us 3x. Now, we've done a little bit solving with quadratics. We will get more into it, especially in Algebra 2. But one of the biggest things is to try to get the x squareds on the same side. So what we can do is subtract x squared from both sides. Now, unlike Algebra 2, when we get to problems like this here, they won't work out nicely like this. And that x squared minus x squared is 0. The other side, x squared minus x squared is 0. So that tells us that 4x is equal to 3x plus 2. Normally, we'll still have an x squared when we start covering quadratics in Algebra 2. But since the x squared's canceled here, so we could subtract the 2, but since we have, I would subtract 3x. Because we have x's on both sides, let's get them together and away from our constant term. And if we subtract 3x from both sides, 3x, 4x minus 3x is x, is equal to 2. And is that the final answer? No, because what did it ask for? ML and JK, so we have to plug it back in. Now, out of all of them, the distance of KN is the easiest one to find because it's just x. So that means that length is 2. For the one up here, we would have 2 plus 2, which is 4. Here we'd have 2 plus 4, which is 6. And lastly, 2 plus 1 is 3. So we're saying that this length is 2, 6, 4, 3. So ML is, yeah, and KJ is, KJ is 8. We won't, because if we're talking about the segment themselves, talking about the line segment, then we would put it. But if we're talking about its measure, its length, we don't include it. So without the line, we're talking about an actual distance or length, a numerical value. If we put the line, we're talking about the segment. Questions on this here? We ready for the next one? So this here, we have a similar setup. And what it's telling us is that x times x plus 6 is going to be equal to x plus 1 times x plus 4. We're going to be multiplying these together. Now, since we have an understanding of what we're actually multiplying, we don't have to write it as Bn times Na is equal to Qn times Np. We don't have to write that out since we know what we're multiplying. Now here we can distribute the x first. X times x is going to be x squared plus 6x. X times x would be x squared. It would, because 2x and then would combine with 6x. They'd be like terms. So we add the square because we're saying it's being multiplied by itself. So exponent 2 is telling us that's how many times we're multiplying it by itself. Since we multiplied x with x, it is now x squared, x times x. Now x times 4 is going to be plus 4x. Then we do 1 times x, which is plus x. And lastly, 1 times 4 is 4. Then we would indeed have 5x, so x squared plus 6x is equal to x squared plus 4x and x is 5x plus 4. Yes, we can subtract x squared from both sides. These will cancel. These will cancel, telling us that 6x is equal to 5x plus 4. Then we can subtract 5x from both sides. 6x minus 5x is, it's equal to now if we plug it back in, we'll find out that the length of BN is 4. NA would be 10, because 4 plus 6 would be 10. QN, 4 plus 1 is 5. And 4 plus 4 is 8. So AB, the length from AB would be 14. And the length from P to Q is 13. Questions on any of these here? Not always. I think that's just how it works for these here. Well, it would be if they were diameter to diameter. Because QP is offset from the center, it has a different length than the other. Any other questions on these here? Yeah, because this would be 10 and 11. Any other questions on these here? Do we feel comfortable with these here? Tangent segment and secant segment theorem. A tangent segment is a segment that is tangent to a circle at an endpoint. So it's a segment that goes to the endpoint outside the circle and goes to one point on the circle. A secant segment is a secant or segment that contains a chord of the circle and exactly one endpoint outside. The part of the secant segment that is outside the circle is called an external segment. And again, very clever with how they named it, because it is a segment line and it is outside the circle, so it is external. Now our first theorem that we have, secant segments theorem. Two secant segments share the same endpoint outside of a circle. Then the product of the lengths of one secant segment and its external segment equal the product of the lengths of the other secant segment and its external segment. So what we're saying is the outside times the whole is equal to the outside times the whole. Outside times the whole is equal to the outside times the whole. So if we look at this here, this first one, we're finding the value of x. So what the theorem states for this here is that RP, the external segment times the whole, RQ, is equal to the external segment, RS, times the whole, RP. External times the whole is equal to external times the whole. Now RP is 9. Now RQ is 9 and 11, so the whole length is 20. Because 90 times 20 is indeed 180. Now the other side, RS, the outside is 10. Now RT would be the whole, yes? Well, how did we find RQ? We did what? 9 plus. So to find RT, we can do what? Now, we already said 9 times 20 is 180. Now, for this one here, we do have to distribute the 10. 10 times 10 is plus 10 times x is 10x. No. No. Yeah, we multiplied those two. I went on and wrote it down.
Since they are straight lines, they can always be 180.
The angle, yes. But since at this point here, we're not actually talking about the angle or degree, we're talking about the actual length. Yeah, this is the first section of chapter 10 that we're actually talking about a length, not a degree measure. We subtract 100 from both sides, telling us that 10x is equal to 80. Then the next thing we can do is divide both sides by 10, telling us x is equal to 8. So find the value of x is 8. So both sides would indeed be 180.
Or is that just how the way this one works out?
Yeah. Yeah, because equality is still the same, because 10x is equal to 80, 80 is equal to 10x. They are the exact same. So this whole length would indeed be 18, and this would be 8. Because 8 times 18 is the same as 9 times 20. Yep, because it just has to find the value of x. We found x. Questions on this here? So looking at this here, we have the exterior times the whole. So for one line, it is 3 times 12. Because we need the whole length, so 3 and 9 would give us 12. The other side would be the exterior, which is 4 times 4 plus x, because the whole length would be 4 plus x. Now on the left-hand side, we have 3 times 12, which is 36. 4 times 4 is plus 4x. Now at this point here, we can subtract 16 from both sides. Exactly. Divide both sides by 4, telling us x is 5. And since it was just asking for the value of x, we are done. Questions on any of this here? Are you ready for the next one? Do we need to see another example of one of these? Because once we get the formula down, these are not. So what would we have? 6 times 15 is equal to 5 times.
Oh, you added. I got it. Sorry.
X plus 5. Now 6 times 15 is, because, well, 30, 6 times, well, 5 is 95 is equal to 5x plus 5. Right. Nope, it's not 90. It would just be 90. Because, yeah, because 6 is 2 and 3, yes? And there's a reason I break it up that way. 2 times 15 is what? 30. Times it by 3? 90. You can break it up into parts. Right, we would subtract 5. 5x is equal to 85. How many times does 5 go into 8? So it goes into it once, which leaves us with 35. 35 is. So x is 17. Questions on this here? 135. Yeah. 25. Ah, right. Yes. Thank you. No. Yeah. I forgot to. Yeah.
So does it still? Well,
Yep. So distributed, and again, this is very common to only multiply the first one. I forgot to multiply the 5 and 5, which should have given us 25. Then we'd have subtracted 25 from both sides, which would have gotten us 65. And we divide both sides by 5. X is 113. That makes a little more sense. Let's make sure. 113. X equals 13. Yeah, because 13 times 18.
yeah. I completely break it apart.
Mm-hmm. 5. Oh. Yep. 13. 13 times. Okay. Questions on any of this here? Yeah. Let's look at this one here. Now, if we look at this here, we have the external times the whole. So the whole is going to be 3 plus is equal to the external times the whole. So we're going to add 2 and 2 plus x plus.
Wait.
Yeah.
Where'd you get the other 3? You have 2 3 at the first one.
3 and the exterior times the whole. Mm-hmm. So if we combine like terms, 3 minus 2 is 1. And for the other one, we have 2. 2 and 1 is 3. Now at this point, we can distribute the 3 here. 3 times x is 3 times 1 is 3. Here we can distribute the 2. 2 times x is 2x plus. We can subtract 3 from both sides, which will tell us that 3x is equal to 2x plus. Then we can subtract 2x from both sides. So x is equal to 3. And that's it. Value of x. Any questions on any of this here? Because if we plug this in, this value would be 4. This value would be 1. So we're saying 3 times the whole, which is 4, which would be 12. The exterior is 2. 2 plus 4 is 6, is 12. So they are the same. Now we will finish this tomorrow. Yes. Minus 25. Divided by 5 is 13. Okay. Yep. Yep, that works.